Hello, this is a review for the problem solving with scientific notation. The first set of problems here are addition and subtraction with numbers in scientific notation, and then part 2 has numbers in scientific notation that are being multiplied or divided or a combination of both. All right, so we see problem 1 is 3 times 10 to the second plus 5 times 10 to the second. When you have problems like this, you have 10 squared and 10 squared. Those are the same base, 10, and the same power, 2. When you're adding and subtracting and you have numbers to the same base and same power, you can simply add the two coefficients together, the 3 and the 5. So this is simply 8 times 10 to the second. Always leave the base and the power the same in that case, at least if the two coefficients add up to less than 10, which they do in this case. You could also convert these into standard notation. This would be 300 plus 500, which is 800, and 800 in scientific notation is 8 times 10 to the second. For problem 2, again, we have the same base and same power, so we can add the two coefficients together. Here I've just made it a little bit different by adding a decimal into it. So 2 plus 1 is 3.1, and then we keep times 10 to the third, so it's 3.1 times 10 to the third. Again, though, you could put them in standard notation first, so this would be 2,000 plus 1,100. Those add up to 3,100, which in scientific notation is 3.1 times 10 to the third. For problem 3, now we have the bases being the same, but the powers are different. So we cannot simply add the 3 and the 7 together to get a 10 or whatever. They're just a whole different type of number. One way to make this simpler is to put them in standard notation. So 3.10 times 10 to the fourth, you could move the decimal 4 times, and you get 31,000. Let me erase that out so you can kind of see it. There we go. And then 7.55 times 10 to the first is the same as 7.55 times 10. 7 times 10 is 70. So 7.55 times 10 is going to be 75.5. So you could write it like this. Now you add them together, you get 31,075.5. Putting it back into scientific notation, you would have to move the decimal till you get to the right of the 3, and you do that 1, 2, 3, 4 times. So it's 3.10755 times 10 to the fourth power. The problem does say here round to 2 decimal places if necessary. So guess what? This ends up being 3.11 times 10 to the fourth. That would be the true answer there. The other two problems, that didn't matter. There's another way to do this, though. So let me show that. We have 3.10 times 10 to the fourth, and we have 7.55 times 10 to the first. Because the powers are different, we can't add them like I mentioned, but we can make the powers be the same and then add them. Well, what we have to do is find the biggest one, which is the 4, and then we need to make the smallest one into a 4. We can do that by adding a 3 here. But by adding a 3, we have to move the decimal for that coefficient to the left 3 times. So it ends up being 3.10 times 10 to the fourth plus 0.00755 also times 10 to the fourth. It's not how you should report numbers in scientific notation, but it does make this possible to add the numbers together. So you have 3.10 and now plus 0.00755 times 10 to the fourth times 10 to the fourth, and you get 3.10755 times 10 to the fourth, which rounds to the 3.11 times 10 to the fourth we saw earlier. So again, same answer, 31,755 rounds to 31,100. Problem 4 has a subtraction, and the bases and powers are the same, so we can do this simple subtraction. You'll notice that we have a coefficient of 2 and then 4, so this is going to end up being a negative number, which is certainly possible in mathematics and sometimes in science. So what you could do is take the 2.65 and subtract 4.36 from it. Good luck with that one. That's kind of messy. So what you should do is just take 4.36 and subtract 2.65 from it, even though that's the reverse order that we see in problem 4. But what we do is take 6 minus 5 is 1. 3, we need to bring up a power of 10, or a factor of 10. 13 minus 6 is 7. And then 3 minus 2 is 1. So the difference is 1.71, but because we did it in the opposite order, we need to make it a negative 1.71, and then we just leave the times 10 to the third in there. And that's it. Again, though, we could put this, or these numbers, into standard form, and we get 2.65 times 10 to the third is 2,650, minus 4.36 times 10 to the third is 4,360. So again, do the reverse, 4,360 minus 2,650. You get 1,710, but that's now going to be negative. Putting it into scientific notation, you get the same number we had earlier. For problem 5, here we're subtracting again. We have different bases, or sorry, same base, different powers. And you could do the same thing we did for problem 3 and move this. In this case, negative 1 is greater than negative 2. So we would move this over just one time. We get 6.7485 times 10 to the negative first minus 0.2367 times 10 to the negative first as well. Then we can just do the simple subtraction. And 6.7485 minus 2.367 times 10 to the negative first times 10 to the negative first. And you get 5,1,834 times 10 to the negative first, so it's 4.3815 times 10 to the negative first, but again, we need to round it to 2 decimal places, so 4.38 times 10 to the negative first. In standard form, it'd be 0.438. So we see the answer right there, 4.38 times 10 to the negative first. So that's a good help there for doing these problems with addition or subtraction within scientific notation. That being said, the other biggest, easiest option is neither of this stuff, but to use your calculator. All right, it does say up here calculators are not allowed, but I'm going to allow you to use your calculators when you're doing this. So please use them. If you don't know how to use it, ask for help. All right, I can help you type the things in. There should be no issue doing that. But moving on to part 2, complete the following problems using multiplication or division. Again, all answers must be in scientific notation and rounded to 2 decimal places if necessary. Now for these, this one's kind of messy, but you might want to put parentheses around it. When you see a number times an exponential thing, just consider that one number. And so I could do this for all of these. You don't have to. They may be written like that, or they may not. But it might help if you're typing these into a calculator to get the right answer. All right, problem 6, we have 1 times 10 to the third times 4 times 10 to the fourth. When you're multiplying or dividing, the bases do need to be the same. and that's going to be the case for everything we see all year. It will be the same, but the exponents don't have to be the same. So this is 1,000, and we have 40,000 for the other one. But as I'm sure you're aware, multiplication can be done in either direction. 3 times 4 is the same as 4 times 3, for example. They're both 12. So I could utilize that to say it's 1 times 4 times 10 to the third times 10 to the fourth. And you could think of this like there's 10 threes, there's 10 threes, there's 3 tens, my bad, and there's 4 tens for a total of 7 tens, which means they're all multiplied together, so you get 10 to the 7th. 1 times 4 is simply 4. So the answer is 4 times 10 to the 7th. Another way to look at it would be, again, in standard form. When you do this, you might want to put it in your calculator, but you have 40,000. That would go to, if you're multiplying it by 10, it would go to 400,000. Multiplying it by 10 again, you get 4 million. Multiplying it by 10 again, you get 40 million, which is 4 times 10 to the 7th. It's the same answer if you're putting it back into scientific notation. You can do that. That's great. You could also just type this into your calculator and it will give you 40 million. But you need to put it into scientific notation after that. Some calculators have a mode of scientific notation that you can just put it in yourself. That would also help. But the last option is to take the numbers. I'm going to do it all the way over here on the right. 1 times 10 to the third times 4 times 10 to the fourth. So the last option here, again, split up the coefficients and the exponents. In this case, 1 times 4 is 4. And now I'm going to take times 10 to the third, and we're going to add 4 to that. Because we saw earlier that we have like the 3 here and we have the 4 there for a total of 7. So we can simply just add the exponents as long as the base is the same. When multiplying, you add the exponents. So this is 4 times 10 to the 7th. For problem 7, we have same base, different powers. In this case, we have 4 times 8. I'm going to split it up that way. Times 10 to the negative second times 10 to the negative fourth. 4 times 8 is 32. And now, again, just as we learned, we can add the exponents. So you have negative 2 plus negative 4, which is really negative 2 minus 4. And negative 2 minus 4 is negative 6. Another problem with this, though, is that we can't have 32. We must have a decimal after the 3. Since it's actually 32, because 4 times 8 is 32, we need to move the decimal place once over. This is a factor of 10 bigger than 1. Well, it's 3.2 factors bigger than 1, and also a factor of 10 bigger than 1. But that being said, we still need to move the decimal place once over, which means we also have to add 1 to that. So this is 3.2 times 10 to the negative fifth. Negative 6 plus 1 is negative 5. All right. Again, we could put it in standard notation. You have 2 zeros and a 4 times 4 zeros and an 8. So yes, 4 times 8 is going to give you a 32. Look at all the zeros here. There's 4, there's 2. You add those together, you get 6 zeros. and a 32. So we're going to go 2, 3, 4, 5, 6. Now the 3, because 8 times 4 is bigger than 10, the 3 is actually going to overlap with this last 0 and be right there. And then this is really 3.2 times 10 to the negative 5th. All right, let me show that up here. I'm going to do the same way for that again. 1 times 10 to the, we'll make them negative values. Negative third times 4 times 10 to the negative fourth. In this case, we have 0.001 times 0.0001, or sorry, 0004, like that. 1 times 4 is 4. But we can add the zeros right here. Put the 1 back outside there. And there's 7 of them. So 1, 2, 3, 4, 5, 6, 7, and then a 4. In this case, if I take the 1 and the 4 times 10 to the negative third times 10 to the negative fourth, we have 10 to the negative 3 plus negative 4 is really minus 4. So we get 4 times 10 to the negative 7th. If we count the zeros over here, we've got 1, 2, 3, 4, 5, 6, 7. Or if we had to move the decimal, it would be 1, 2, 3, 4, 5, 6, 7 times. So because 1 and 4 multiply to a number less than 10, we just put the 4 at the tail end of the numbers, the zeros. Whereas for number 7, because 8 times 4 is bigger than 10, we kind of overlap the last one. Another thing you could do even for problem 6, the way it is. There's 1,000, there's 10,000, there's 3 zeros, there's 4 zeros, 3 plus 4 is 1, the number 4 there I should say, and then 1, 2, 3, 4, 5, 6, 7 zeros, which comes out again to 40 million. You're just adding up the number of zeros for these. There's so many ways to do these. Pick what works best for you, what makes most sense to you, or what's the quickest for you to save time. Problem 8, we have 7 times 10 to the 5th divided by 3 times 10 squared. So this is 7 times 10 to the 5th divided by 3 times 10 squared. It certainly will not hurt you to rewrite that expression as a fraction. We can split up the coefficients from the exponents and get 7 thirds times 10 to the 5th over 10 squared. 7 divided by 3 would be the same as like 2 and a third. So this is 2.3 repeated. I'm going to put those right there. And then when you're dividing exponents, this is 10 to the 5th minus the second, which is 10 to the 3rd. That's the answer to that. That being said, though, we could put this as 10 to the 5th being 100,000, because there's 5 zeros, divided by 100. When you have simple multiples of 10 there, you can simply cross out the zeros like that. And this ends up being 3 zeros remaining over 1, which is 1,000. We also have 2.33 from the 7 over 3 is 2,330, which is still 2.33 times 10 to the 3rd, the same number you get earlier. 7 and 3 is, when you divide them, is bigger than 1. So we leave the exponent as that 10 to the 3rd there. Problem number 9, kind of run out of space here, but rewrite it. 6 times 10 to the 4th divided by 4 times 10 to the 5th. Now, again, go ahead, separate out the coefficients from the exponents. 6 over 4 times 10 to the 4th over 10 to the 5th. 6 divided by 4, you could simplify to 3 over 2. And 2 goes into 3, 1.5 times. And so you get 1.5 from those. But also 10 to the 4th would be 10,000 over 100,000, 10 to the 5th. Cross out the zeros, and now you get 1/10, which is the same as 10 to the negative 1st. So the answer here is 1.5 times 10 to the negative 1st. You could also take 4 minus 5 and do that, and it's -1, however you want to look at it. All right, and the final one, number 10, we have 3 times 10 squared times 5 times 10 to the negative 4th, divided, all of that divided by 7 times 10 squared times 7 times 10 to the negative 3rd. Again, I would take all the coefficients, separate them out from all the exponents, and you get 3 times 5 divided by 7 times 7. And then you have 10 squared times 10 to the negative 4th over 10 squared times 10 to the negative 3rd. Well, an easy thing to do is to find common factors in the numerator and denominator. The coefficients, nothing is common to either, so you leave those alone for now, but you have 10 squared and 10 squared. Those can cancel out. 10 to the negative 4th is the same as 1 over 10 to the 4th, which is the same as 1 over 10,000. And 10 to the negative 3rd is the same as 1 over 10 to the 3rd, or 1 over 1,000. So 10 to the negative 4th divided by 10 to the negative 3rd is 1 over 10,000 divided by 1 over 1,000, which is messy. But we have 1 over 10,000 divided by 1 over 1,000. You might remember rules of multiplying or dividing fractions is if you're dividing, flip the fraction and multiply it instead. So you get 1 over 10,000 times 1,000 over 1 is 1,000 over 10,000. Cancel out zeros. And now you get 1 over 10, which is 10 to the negative 1st. All right, so all of that from there. And then you do 3 times 5, which is 15, over 49, which is 7 times 7, and that would be times 10 to the negative 1st. The other option is you take, like, after you cross out 10 squared over 10 squared, you have 10 to the negative 4th over 10 to the negative 3rd. Anytime you have a negative exponent and it's in either the numerator or denominator, you can flip it to be on the other side. So you could change this to be 10 to the 3rd over 10 to the 4th, both positive. And now you get 10 to the 3 minus 4, which is 10 to the negative 1st again. You could also take 10 to the minus 4 minus negative 3. A negative of a negative is positive. So you get 10 to the negative 1st again. All right, and so those are certainly different ways to get the same result. And then you need to combine that with 15 over 49, which if you do this in your calculator, you get 0.306. I'll put a 1 there, that's the next number, and times 10 to the negative 1st. Because this is less than 1, it's going to reduce the exponential part by 1 again. I could rewrite it as 3.061 times 10 to the negative 1st. Let me put that in parentheses there, times 10 to the negative 1st itself. And now we've combined those, and you get 3.061 times 10 to the negative 1 plus negative 1. Which comes out to that. All right. And again, you could do this all in standard notation if you want. All right, you got 300 times 0.0005 divided by 700 and 0.007. That's messy. And so you have these decimals, there's big numbers, there's small numbers. It's kind of messy. I wouldn't really suggest doing that unless you just want to type those in that form into your calculator. What I would suggest when you're doing things in your calculator like this, put parentheses around the numerator, put parentheses around the denominator. It'll help you out. But either way, when you do that, you get 0.03061, and we're going to round the number to 2 decimal places again, so it's 3.06 times 10 to the negative second in scientific notation. All right, so that is the answers to this review guide, at least showing you how to do that. I'm going to also post just a page with the answers so that you can see that without all of this mess.